Okay, so 5 properties today that we're going to talk about. Okay? So before we start talking about the properties, let's talk about the difference between, or what makes an exponential function exponential. Okay? So a linear function, you change by a constant. Okay? The difference between 2 consecutive points is a constant. Okay? If you're adding 5, you're always going to be adding 5. Okay? So if it starts out at 100, then it goes to 105, then it goes to 110, 115, 120, 125, and so on and so forth. It always stays constant. It makes a line. Linear functions make lines. Okay? Exponentials, also the change is constant, but the constant is a percentage. Okay? It's changing by a constant percentage. So it doesn't always end up being equal change. Okay? If I am adding 5% to something, okay, and I start at 100, okay, so let's look at the graphs of what I'm talking about here. Okay? So on the left, I still forgot to change those. This should be an X. Those X's. Okay? All right? So on the left here, it's linear. When X is 0, Y is 100. Okay? And then as X increases by 1, Y increases by 5. So I'm going up by 5 every single time. And that equation would be Y equals 5X plus 100. Y-intercept of 100, slope of 5, looks like that. Fantastic. Okay? Right? That's a linear equation. Okay? An exponential equation, when X is 0, Y is 100, so we have the same starting point. As X increases by 1, Y increases by 5%. So there's 5% growth. So at 1, but the value of my function is 105. So they're equal there. But at 2, the value of my function is 110.25. That's a little bit more. At 3, it's 115.7625. At 4, it's 121.550625. Okay? And so on and so forth. The equation here is Y equals 100 times 1.05 to the X power. What do you notice about exponential equations? The variable is in the exponent. Yep. Okay? That's what makes an exponential equation an exponential equation. So when you go through and you are looking at equations, if the variable is in the exponent, that's an exponential equation. and then we have to use the stuff that we're learning this week to solve it. If it's a regular old equation, you go through and you solve it the regular old way. Try and get the variables on one side, the numbers on the other, try and factor, all that different stuff. Okay? But when the variable is in the exponent, we have to do something different. Okay? And that something different is we have to use logarithmic equations in order to solve. Okay? Now, there are two types of logarithmic equations. There's regular logs and there's natural logs. Okay? A regular log looks like this. Okay? It's got a base and it's got another number in it, and that other number is called the argument. So you've got the base and you've got an argument in a regular log case. Both the base and the number must be positive. If they're not positive, you can't do it. Wake up. Sit up, wake up, be awake. Be active. Be an active participant. Okay? So you can't have a negative base. You can't have a zero base. Okay? The number's got to be positive. Okay? Now, one other note here is that if, by some reason, you don't see a base, so if the person that's writing it didn't write a number down for that base, it is assumed that it is base 10. And that's called a common law, base 10. Your scientific calculator has a log key on it, and that log key is log base 10. Okay? The other kind of log is something called a natural log. Natural logs do not have bases because the base is E. It's log base E is natural log. E is a special number. It's called Euler's number. It's E. It's 7.182819, something like that. I don't know, that far. Yeah? Right? It's kind of like pi. It goes on forever. It's irrational. Yeah? Yeah? So, get it in your heads. Never to write log base E. Okay? Don't write Loge. Okay? Okay? Loge is bad. Good seats at Miller Park. Bad in math class. So, our first property forms, whatever you want to call it. Okay? So the first of the 5 things that you need to take away from today. And this is probably, I put it first because it's the most important one. If the sooner you get this slide memorized, the easier things will get for you in this chapter. Okay? So you've got an exponential form of an equation. Okay? You've got some base to an exponent equals some number. You know it's an exponential form because you see an exponent. Okay? You don't see the word log. That's why it's not logarithmic. Okay? You see an exponent, you don't see a log, it's exponential. You see a log, you don't see an exponent, that's logarithmic. Okay? So that's the exponential form. The logarithmic form of the exact same equation, so much so that they are equal in what they do, is log base b of the number equals the exponent. Now, I told you on the last slide that the base, in the logarithmic form, the base, so that's b here, and the number, which is the hashtag here, have to be positive. That still holds. That's one of our rules, is that b and the number are positive. Always. Always positive. If they're not, you're done, because you can't do anything with it. If b is negative, or the hashtag is negative, you're done. Okay? You'll get an error message. Okay? The second rule that I'm going to add in here now is that because we are solving stuff, or we're going to use this to solve, is that b, our base, can't be equal to 1. Got to be something other than 1. Because 1 to any power is 1. So there's no need to solve for that. Okay? Now, when we get into solving equations tomorrow and the next day and next week and up until the end of first semester, when we get into that, if it's in exponential form, we're going to solve it by putting it into logarithmic form. If it's in logarithmic form, we're going to solve it by putting it in exponential form. Okay? You use the one to solve the other. Okay? Which is why it's so important for you to have this memorized, or to dig deep into the file cabinet that is your brain and find this file, okay, that you learned last year in Algebra 2. Okay? Quicker you know that, faster you get on this stuff. Okay? Now, we will, part of your homework this evening, sorry I lied to you, okay, part of your homework this evening, I made a homework sheet today, okay, is you're going to switch forms with them. Okay? So I'm going to put up a true statement here, log base 7 of 49 equals 2. That's a true statement. Okay? Log base 7 of 49 does equal 2. Because logs find exponents. Okay? So what exponent do I have to put on 7 to get me 49? 2. Okay? Logs are exponent finders. Okay? So that's logarithmic form. Exponential form here would be 7 squared equals 49. Okay? Changing forms with it. Okay? So, what I would like you to do now is I would like you to change forms with that one. and that one. And this one. Change forms with those. Here should have gotten 5 cubed is 125. Yes? Here should have gotten log base 8 of 24 equals x. Yes? Check your settings for the red sheet. Here, how many people wrote down log base e of y equals 4? Be honest with yourselves. Did ya? Is it right? Because what should have you written down? Natural log of y equals 4. Log base e, remember, big old slash through it. Okay? Log base e, big old slash. Natural log instead. Okay? So switching forms is going to be a crucial component to your work starting tomorrow. Okay? The 3 properties of logs are going to be another crucial component tomorrow. There's 3 of them. First one is, again, I want b to be a positive number not equal to 1. And I want m and n to both be positive. That's going to be your hashtags now instead. Okay? Because I need to make it be 2 of them instead of just 1. So, first one is the product property. The product property says that if I am multiplying 2 things in a log, I can break that up into 2 separate logs. Or if I'm multiplying 3 things, I can break that up into 3 separate logs. Okay. All with the same base. Next one is the quotient property, which says that if I am dividing something in a log, I can break that up into 2 or more logs, again, but now with subtraction. Okay? Multiplication goes with addition, subtraction goes with division. And my last one is the power property. The power property says that I need to, or if there is an exponent, I can put that exponent out in front of my log. Now, there's 2 ways to use these properties. The first way is called expansion, okay, where you expand a single log into a string of the same logs. Okay? Not a fan of it, okay, but that's working these properties going to the right. Okay? So you take 1 log and you make it become multiple logs going to the right. Not a fan of it. Don't really use it. Okay? But we will use it going back to the left, and that's called condensing logs. Okay? When we take multiple logs with the same base, and we condense them into one log. Because if we're solving these we're solving equations with logs, we can only have one log in our equation. If we're solving and we have two different logs with two different bases, that's pretty tough. Not the funnest to do. Okay? But if we have one log with one base, we can switch that to exponential form. Okay? All right. So let's try some expansions and some condensings. Okay? So here we got a log with a base. It says we want to use the properties to expand it. Okay? Well, I am multiplying in here, correct? 3 times x. So that's going to be plus or minus when I expand. That's going to be plus. So this becomes log base 3 of 3 plus log base 3 of x. Agree. Use the product property. Okay. Now, just like with fractions, we have to reduce at the end. Okay? So if you have a log with a variable in it, can't reduce it. Okay? Can't reduce it if there's a variable in it. So log base 3 of x, non-reducible. Okay? But if you have a log with a number in it, you always have to check to see if it can be reduced. Okay? Earlier, I said that logs are exponent finders. And they are. They're exponent finders. So what exponent do I have to put, or can I put on 3 to get me 3? Exponent to go on 3 to get 3. 3 to what power is 3? 1, right? Okay. So this log base 3 of 3 is 1. Okay. If we go back to the first example that we had when we were switching, log base 7 of 49 equals 2. What exponent do I have to put on 7 to get 49? That's 2. So if I wrote down log base 7 of 49, I could reduce that, simplify it, if you will, to 2. Okay? Okay. What I'd like you to do now is I would like you to expand these 2 logs. On B, you should have gotten the natural log of x minus the natural log of 5. On C, you should have gotten 3 log base 7 of x. Okay. Condensing-wise, now we're going to take logs, multiple logs, and we're going to condense them down into 1. If you're in a condensing problem and you have your answer, you write your answer out, and you write log or ln more than once, you haven't gone far enough, or you've done something wrong. Okay? Because when we condense them, we're going backwards now down into 1 log. First check you have to make is that the bases are the same. If the bases are different, you cannot condense them. The bases have to be the same. And those are locked in, non-movable ones. So those 2 are the same. So my answer here is going to have log base 6 in it. Okay. subtraction of two logs. Is that product, power, or quotient? That's quotient, right? Okay. So quotient says we divide, right? Left divided by right. So left is 8, right is 9, and then I look to see if that's reducible. Not. Okay. So that's my answer. Log base 6 of 8 ninths. Condensed one single solitary log. You now condense those two. I get the natural log of 10x cubed on the E. And I get log base 2 of 16x cubed for the last one. Questions on expanding or condensing? So we've done 4 of the 5 things that we need to get done. The last one is something called the change of base formula. We've been talking about, and we did this one, we did log base 7 of 49 equals 2. What exponent has to go on 7 to get me 49? And it's been nice and pretty. Okay? But what about when it's not nice and pretty? What about if it were log base 7 of 28? What exponent do I have to put on 7 to get me 28? Okay. Yes, 28 is a multiple of 7, but it's not a power of 7. It's not 7 squared, or 7 cubed, or 7 to the 4th power. It's 7 times 4, and that doesn't help me. Okay? So we have what's out there called the change of base formula. Because your calculators, your scientific calculators, are limited in the 2 bases that they can do. They can only do base 10 and base E. Well, there's a whole multitude of different bases out there, like log base 7 of 28. Okay? Okay? So the change of base formula allows us to evaluate any log under any condition. Okay? So we take the log of the argument, that's the A part, and we divide it by the common log of the base. Okay? So those are log base 10s. If you're not a big fan of common logs, you could use natural logs. The natural log of the argument divided by the natural log of the base will get you the same answer. Okay? So, what I'd like to do now is I'd like to evaluate using your scientific calculator. If you have one, get one out. Oops, let me back this back up a little bit. Let's get that in there. I want to know what log base 3 of 34 is. Okay? I know that it's bigger than 3 because 3 to the 3rd power is 27 and 3 to the 4th power is 81. So I know that since 34 is between 27 and 81, that log base 3 of 34 has to be between 3 and 4. Okay? So when you're typing it in on your calculator, depending on the type of calculator that you have, most of you, can I borrow this for 2 seconds? Most of you have this kind of a calculator. Okay? And when you type it in on the TI-30s, when you hit log or when you hit natural log, one of the two, it looks like that. Right? So when you type that in, I want to do log of my A, so that's log of 34. I have to close that parentheses. It's the most common mistake, is not closing that parentheses. Then I'm going to divide that by log, and again, it's going to open up a set of parentheses for me, and I'm going to put 3 in there, and I'm going to close it. When I do that, you should get on your calculator 3.2098 something, something, something. If you don't have that on your calculator right now, let me know, and I'll see what you did wrong. Yours might be a little different. Yours is a Casio. So you're going to go 34 log divided by 3 log equals. Okay? Because you can't see what you're typing in. Now, check it the other way too. Check it if we get the natural log, and again it will open up a set of parentheses, and you're going to type in 34 and close that off, and then the natural log of open parentheses, 3, close it off. Should give you the same answer.
So you can choose which one you want to use.
Blue or green, but you can't make a blue-green. You know what I mean? You can't make a blue-green fraction. Yep. So it's got to be logs or natural logs, top and bottom. Yep. You can't do one log and one natural log. Yep. Everybody good on that? Okay. Now, let's flip those numbers around and let's see what happens. So find me what log base 34 of 3 is. Wait, I got it written down right here. I need to come borrow that water. I got 0.3115. Agree? Okay. One more. Log of, let's go, give me a number. Log of what? What? Can't do it. Got to be a B. B can't be 1. 24? Okay. Give me a fraction smaller than 1. So top is smaller than bottom. 2 numbers. Actually, just give me 2 numbers. 14 and 1,000? Okay. What? Your calculator's doing it. Right? Find it for me. What? I get negative 1.2 3, 4, 3, 2. Yes? Now, my question to you is this. Thought-provoking question to end the day. Is that legal? What? What's not positive? Or, let me tweak my question. What has to be positive in this scenario? The base has to be positive, right? Is 24 positive? Yep. Okay, so we met that one condition. What's the other thing that has to be positive? The other black number, right? The argument is what we called that one. Is 14 over 1,000 positive? Yeah. So I've met my two conditions, right? So my question to you is, logarithmic functions find what? What do they find? Logs find what? Logs find what? Exponents, right? Can I have a negative exponent? No. No, doesn't make it imaginary. Can I have a negative exponent? Yeah. I can have a negative exponent. So this is still legal. Okay. These two numbers here have to be positive. This number and this number have to be positive, but this number can be positive or negative, or it can be 0. Because 0 is an exponent, right? 0 is an exponent. Tonight for your homework, I came up with a worksheet for you earlier this morning. Fear not. Yes, there are 22 problems on it. 5 minutes. Maybe.
Liz, how long are we covering this for?
This week and next week. Your test is on next week, Thursday. You weren't here when we talked about it, but yeah. Your test is next week, Thursday, the 10th.
When are you handing out our study guide for
The 10th.
Really?
Yep. Because then the 11th and the 14th, we'll have the class review time.
Last time we had someone